Hey Geometry, we're starting a new unit today. The unit is on similarity, proof, and trigonometry. There's 34 lessons again, so this will take us past Christmas break, but that's okay. We're going to get into some trig, which I think is tons of fun. And for those of you that have missed some algebra, we'll see it then. Otherwise, yeah, we're going to start talking about scale drawings, and then dilations, and then similarity and dilations. Tons of fun. First of all, if you, we all have phones. We all look at pictures on our phones. This right here is a common feature on cell phones and tablets, and it's the ability to scale. That is to enlarge and reduce an image by putting a thumb and an index finger to the screen and make a pinching to reduce or spreading to enlarge. So I can go like that and like that. Okay, I'm making it smaller by pinching it and making it larger by spreading my fingers out. Okay, hope you're not getting dizzy. And I can undo everything I've done to get it back to normal. Cool. So this is actually a code that was written to stretch and shrink things. And today we're going to review a concept that is key to scaling drawings. First of all, above is a picture of a bicycle. Okay, which of the images below appears to be a well-scaled image of the original? Why? This one looks like we've shrunk it down from top to bottom. This one looks like we squished it from left to right. This one right here, it has held its original shape. It's just gotten smaller. That's what it means to be well scaled. It's the initial intent of scaling. So let's get into how we actually scale a drawing. What we see here first, it's our first example, and I'm going to tell you guys right now, we have two examples. So in an example, we have one example, then an exercise. Then we have, let me look, another example, and then 3 exercises. I do not necessarily need you to construct the exercises in your classwork. I would like you to construct 1 or 2 to get the hang of it, but you should be able to get the hang of it watching the video without too much work on your own. This is that type of problem. I don't need you to practice on your own as much during the lesson. You will get that chance to practice during the problem set. So the video may be, I don't know, a little long, but you really might just be able to sit back and watch. So it took me a long time to construct everything, but I don't need you to do the same thing. Get it? All right. So first, we use construction tools to scale a drawing of triangle ABC with a scale factor of 2. That means we're multiplying everything by 2. Okay, we're doubling everything, if that makes sense. And I used a compass and a protractor, or a compass and a straight edge. So first of all, you see triangle ABC. I took my compass with the pointy end here and the pencil there, and I measured it. Like, all right, measured that. Then I picked up the pointy end and put it on B and wrote the measurement. So in essence, this segment is equal to that segment. Okay, and this segment is equal to that segment. So pointy end, pencil, pointy end, pencil. So I've doubled my length. And then I can connect C prime and B prime and get a new triangle with a scale factor of 2. I guess I should say first I had to extend the sides to do that. But that's not the only way to do it. Okay, I did it 2 more times. Okay, the other way that you can do this process is by copying angle A. And we learned how to copy angle A a long time ago. So first you draw a line segment, and then you come over to the original triangle and you measure, pointy end, pencil, pointy end, pencil. So we know B prime. Then go ahead and draw a circle at point A of any radius. Okay, we did the same circle here. And then we did pointy end, measure the opening of the angle. we did that on the original triangle. So we measured the opening of angle A, and then we copied the opening of angle A on the circle. Okay, and we knew where to draw the ray AC through, because we drew a circle, we measured the opening of the original triangle, the opening of the original angle, copied the angle, and then drew straight through. And once we drew that straight through, then we could measure the distance, double the distance, and connect the points. Cool. All right, so this was the practice exercise. You know, first we do an example, show you what's going on, then we practice it. Okay, this would be a scale factor of 3. That means we triple it. We multiply everything by 3. If I look, I've got the pointy end on D, measure to F, pointy end measure, pointy end measure. I've got 1, 2, 3 to F prime, and I draw a dot. There's F prime. Here again, pointy end measure, pointy end measure, pointy end measure. I've got 1, 2, 3. E prime. I know F to E prime, and I draw a straight line. Or I can copy the angle. Okay, I just drew, honestly, this is me drawing a line, a line segment, circle, go to the original and measure the opening, draw a segment, and then measure 1, 2, 3 segments. 1, 2, 3 segments, and then connect the dots. Excuse me, I'm so sorry. But this is what I want to make sure you saw. You don't have to, when you make a triangle bigger, go this way every time. Okay, this time I went out this way. Okay, I measured, that's a lot of ink. This time I measured out here. And I went, you know, pointy end pencil, pointy end pencil, pointy end pencil. 3 segments out, 3 segments out, drew a new triangle. Or here I went up this way. Okay, 1, 2, 3, 1, 2, 3, connected the dots. Okay, it doesn't matter. Okay, we're going to get the same triangle no matter which way we scale the drawing. All right, example 2. Use construction tools to create a scale drawing of triangle XYZ with a scale factor of 1/2. Here, I am making it smaller. And to make things smaller, like for 1/2, you find the midpoint. Okay, and you guys all know how to find the midpoints. We practice that a lot with our 9-point circles, right? So I went down XY and I found the midpoint. Then I went down YZ over here. Oh goodness, down here, sorry. Down here, and I found the midpoint. Okay, I found 2 midpoints. I can connect those midpoints, and my new triangle is right there. 1/2 as big. Cool? But what do we do if it's a 4th? Goodness, a 4th. Okay, well, all I did there is I found the midpoint twice. I have PR, and I found the midpoint. And then we come over here. Now I have P prime R, and I found the midpoint again. And I did the same with, what is this, QR. I found the midpoint, and then I found the midpoint of Q prime R. And this right here is my little itty bitty quarter triangle. Okay, I've got a quarter scale triangle. And it's pretty small, but we did it. Okay, I found the midpoint, which is 1/2, and then I found the midpoint of that, which is a quarter. And we're done. All right, now here's where it gets a little bit different. Triangle EFG is provided below, and one angle of scale drawing E prime, F prime, G prime is also provided, just one of the angles. Use construction tools to complete the scale drawing so that the scale factor is R equals 3. What properties do the scale drawing and the original figure share? Explain how you know. Okay, don't zone out on me now. We haven't talked about this yet, and we need to talk about it. But let's construct it first. So I had this angle. I extended the lines. That's all I did. I extended the lines. Then I went over here and I measured E to F. Sorry, G to F. I measured that with my compass. Pointy end, pencil. Then I put it down here. I went pointy end, pencil, pointy end, pencil, pointy end, pencil. I have 1, 2, 3. Then I did the same up here. I measured G to F, or G to E. Okay, pointy end pencil, pointy end pencil, pointy end pencil. I now have the top. Okay, I went double tick, double tick, double tick. And now I have E prime and F prime, drew a straight line, and I have a triangle that is a scale of 3 bigger than the original one. Now, what properties do scale drawings have? What properties do the scale drawing and the original figure share? Are the segments of the triangle the same? Well, no, because we measured this one and multiplied it by 3, so the segments certainly aren't the same. None of them are. What about the angles? Are the angles the same? Well, for instance, on this drawing, like we just copied the angle. That's all they did. They copied the angle, and then they got the sides. So, in actuality, angle G prime is equal to or congruent to angle G. Angle F prime is congruent to angle F, and angle E prime is congruent to angle E. Okay, angles are congruent in scale drawings. Sides are proportional. Write this down. It's not really spelled out in your lesson, and it's very important. All right, let me show you. So we had a triangle, and I'm just sketching it. I know it's not going to be exactly the same. Let me get what they were. EFG. Let's find EFG. I could remember how it was labeled, so I had to look it up. And then we went bigger. Those are great, aren't they? E prime, F prime, G prime. We said that the angles are congruent, so E is congruent to E prime, F is congruent to F prime, and G is congruent to G prime. Okay, that's a true statement. Now the sides being proportional, this is where we've talked about ratios in the past. Not in geometry, but you've talked about them in the past in algebra, and we're talking about them in geometry again. So EF, side EF, is proportional to side E prime, F prime. And that's equal to FG over F prime, G prime is equal to, what are we left with? EG over E prime, G prime. Okay, what is true is the top, my numerator, and my denominator are proportional. So to go from EF to E prime, F prime, we did times 3, times 3, times 3, straight across. Everything's times 3. That means that it's proportional. Okay, this was 1 tick, this was tick, 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 you know, because we used our pencil to draw our arcs to measure things. And we'll get to actually it's your last question in your problem set that talks about proportionality. So this is why this slide is important in our lesson. So yes, what we're saying to answer the question is by measurement, we can see that each side is 3 times the length of the corresponding side of the original figure, and that all 3 angles are equal in measurement to the 3 corresponding angles in the original figure. Cool? Cool. All right, number 4. Triangle ABC is provided below, and one side of the scale drawing A prime, B prime, C prime is also provided. Use construction tools to complete the scale drawing and determine the scale factor. Okay, we don't know the scale factor at all. They just gave us a side length, right? So here we need to remember how to copy angles. So what I did here, I've got the original triangle and the new side length of the triangle. Okay, first, if I come over here, I copied angle A. Let's just highlight it. 1 second. So first I copied angle A. And I just made it as big as I could. Okay, I drew a circle around it. I measured from using my compass from this side of the arc to this side. Then I copied it over here, here to there. And I knew that I could make my arcs right like that. Okay? Then I copied angle B. Let's get green out. No, angle C. I'm sorry, I copied angle C. Right over here. Actually, I didn't go that far because I didn't need to. I copied angle C, and where the side of, get my red pen, right here where they both intersect, that's B prime. Okay, so when you get to your problem set, if you don't remember how to copy angles, I would love to work with you and show you, because we've learned it in the past, and I didn't spend the time to record actually me copying the angle. So for here, we had the segment. First I copied angle A, then I copied angle B, and where they intersect, sorry, angle C, and then I copied angle C, and where they intersect was point B prime. But let's erase that mess. And I can't. There we go. Let's move on to the next one. That's it. We're done. Excellent, excellent work, everyone. Okay? If you have any problems tomorrow with your problem sets, I would love to remind us how to use our compasses and our straight edges to scale things, to multiply, to make our sides longer and shorter. Tons of fun, though. Good job today.